So we have finished this first internal in the previous video and we are going to do the second internal in this video. So welcome back to the video. After the first internal solution, you have to see the second internal solution. So we have discussed already this table and these questions in the first internal solutions. So now we're gonna see the second internal solution. So first, what are these questions about? These are right algorithms for decision tree inductions. This questions and this whole question paper is about the decision tree algorithms, information gain, entropy, and attributes and all this. So first you need to watch the first video for this second internal so that you can get some knowledge about the this all keywords like entropy and decision tree and Gini index, information gain, impurity and all this. So yeah, let's begin with the first question, that is write algorithm for decision tree induction. The first question is write algorithm for decision tree induction. So let's see the first question. So the input will be training data set D with tuples and their class labels attributes A available for splitting. Okay, so the algorithm will be, if all tuples in D belong to the same class C, create a leaf node labeled C. Okay, if A is empty, create a leaf node labeled with the majority class in D. Otherwise, select the best attribute, best A best, for splitting best on an attribute selection measure. Create a decision node labeled best A best. For each value V of the A best, partition D into subset dV based on best is equals to A best is equals to V. Recursively apply the algorithm to each subset dV with the remaining attributes. Okay, and the best A minus A best output should be a decision tree, obviously. So this is the solution for the algorithm, write an algorithm for the decision tree. Now the second question is write what is attribute selection measure, explain three of them. Okay, so an attribute selection measure is a heuristic for choosing the splitting test that best separates a given data partition D, okay, of class level training tuples into single classes. If it can split D into smaller partitions as per the results of the splitting criterion, ideally every partition can be pure. That is, some tuples that fall into a given partition can belong to the same class. Conceptually, the best splitting criterion is the most approximately result in such a method. Attribute selection measures are called as splitting rules because they decide how the tuples at the given nodes are to be divided. The attribute selection measure supports a ranking for every attribute defining the given training tuples. The attribute having the best method for the measure is selected as the splitting attribute for the given tuples. If the splitting attribute is constant valued or if it is restricted to binary trees accordingly, either a split point or the splitting subset should also be decided as an element of the splitting criteria. The tree node generated for partition D is labeled with the splitting criterion. Branches are increased for each result of the criterion and the tuples are isolated accordingly. There are three famous attribute selection measures, including information gain, gain ratio, and Gini index. Okay. Information gain. Information gain is used for deciding the best features attributes that render maximum data about a class. It follows the method of entropy while aiming at reducing the level of entropy starting from the root node to the leaf node. Let node n defines or hold the tuples of partition D. The attribute with the largest information gain is selected as the splitting attribute for node n. This attribute minimizes the data required to define the tuples in the resulting subdividend and reflects the least randomness or impurity in this subdivide. Gain ratio. The information gain measure is biased approaching test with several results. It can select attributes having a high number of values. For instance, consider an attribute that facilitates as unique identifier including product ID. Now, a split on product ID can result in a huge number of partitions, each one including one tuple. Because each partition is authentic, the data needed to define data set D based on this partitioning would be info product D is equals to 0. Gini index. The Gini index can be used in CART. The Gini index calculates the impurity of D, a data partition or collection of training tuples as Gini D is equals to 1 minus M. Summation of I is equals to 1 P to I Gini D in the brackets is equals to 1 minus summation of I is equals to 1 MPI2, where Pi is the probability that a tuple in D belongs to class Ci and is calculated by Cid in the mode divided by mode D. Okay, so this is all about the question, which is attribute selection measure. This is how in 3 ways we can select the attributes. So the summary of this question will be, in these 3 ways we will going to solve this selection measure. Okay, this is how we will going to selection measure in 3 ways. That is, in the information gain ratio and Gini index. Okay, now coming towards the next question, which is the third question. Define a mathematical expression of information gain, Gini index, reduction in impurity. So let's go through the third question. So in previous question we have already seen what is information gain, Gini index. So let us have the formulas for information gain and Gini index, like have the mathematical expressions. So the Gini coefficient captures how far the Lorentz curve falls from the line of the equality by comparing the area A and B as calculated in the following way. Gini coefficient is equals to A divided by A plus B. Okay, so visual explanation of the Gini coefficient. The bar chart on the left shows a simple distribution of income. Okay, the total population in splitting up in 5 parts and ordered from the poorest to the richest 20%. The bar chart shows how much income each 20% part of the income attributes earn. Okay, the chart on the right shows the same information in a different way. Both axes show the cumulative shares. The poorest 20% of the population earn 5% of the total income. The next 20% earn 10%, so that the poorest 40% population earn 15%, etc. The curve resulting from this way of displaying the data is called the Lorentz curve. Okay, this is called the Lorentz curve, this one. Okay, now if there was no income inequality, the resulting Lorentz curve would be a straight line, the line of the equality. The largest area A between the Lorentz curve and the line of the equality means the highest level of inequality. This area is showing the highest level of inequality is here. Okay, now the ratio of A divided by A plus B is therefore a measure of inequality in the referred to as the Gini coefficient, Gini index, or simply the Gini. Okay, so this is the graphs and this is the paragraph which is defining this graph. Okay, so I have already explained this by this graph, so you can see the graph here. Now let's coming towards the next question, that is, explain concept of overfitting and tree pruning. Now the concept of overfitting and tree pruning we will going to see is, overfitting occurs when a decision tree captures noise in the training data and makes predictions that do not generalize well to new unseen data. Okay, it often results in a complex tree with too many branches capturing random fluctuations instead of the underlying patterns. Tree pruning. Tree pruning is a technique to reduce overfitting by removing branches that do not significantly contribute to the predictive accuracy of the tree. Two common pruning techniques are pre-pruning and post-pruning. Pre-pruning stops growing the tree earlier based on certain conditions. Post-pruning grow the tree to its maximum size and then prune branches that do not contribute significantly. Pruning helps create a simpler and more interpretable tree that generalizes well to new data, improving the model's performance on unseen instances. So this is the last question of the second internal. Thank you very much for watching the video.